All right, so here I am on page 3, section 3 and 4, talking about two measures of center and measure of variance. First of all, let's go ahead and start talking about measures of center. Local fast food restaurant calculated the wait time of the 12 most recent customers in minutes. The times of the customers had to wait are listed below, ranging from 5.1 to 5.2 all the way up to 10. The first question is asking you to find the mean, median, mode, and mid-range, all of those measures of center for that data. To do that, I'm going to utilize the calculator. Okay, so I've got to first start by putting the data into the calculator in a list. So I press the stats button. I'm going to edit my list, so I'm going to press enter, and then I can just type in the data. Type in the data really quickly, 5.1, enter. As soon as you type in the data, you can just press enter. It'll automatically move down to the next input. You'll notice the last entry, I have L1. That means I'm on list 1. The data value, data input number 12, and the data value is going to be 10. When I press enter, I should see my list of L1, and I can go through the entire list to make sure I've got it all accurate. Now, I want to do some calculations on this list, so what I'm going to do is I'm going to press second quit. You can actually do this from the stat menu. I just like to do second quit to clear out and go back to where I'm thinking. So either place, stat menu or second quit, I'm just going to press the stat button again. I'm going to go to calc, and I'm going to calculate one variable statistics. When I press enter, it asks me what list do you want to do one variable statistics on. I'm going to just choose L1. I'm going to arrow down and press calculate. I get all the data that I need. X bar is going to be my mean. Sum of x is sum of x squared. Capital S or SX is just the standard deviation of a sample. Sigma x is standard deviation of a population. Arrow down, I get the other values, and I can see that my mean and my median are very quick and easy to gather. All right, so now using the data from the calculator, we already have values for my mean, median, and then I can quickly determine my mode and my mid-range. From the calculator, I know that my mean is going to be 6.73. My median was going to be 6.35. My mode is the number that shows up the most often in my data set. And if I look through my data, I can see that the number that shows up the most is going to be that 5.2. So I can actually just determine that mode directly from my data set. And then remember the mid-range, that's the one that you've never used before other than this class. And mid-range is going to be the average of the max and the min. So in this case, it's going to be the average of 10 and 5.1, or 10 plus 5.1 divided by 2. What you end up doing when you get that is you're going to get 15.1 divided by 2, and that's going to give you a value of 7.55. So we've got our values for all of our measures of center. I've got them color-coded for you here on the screen. And the next question is asking you to, if you were working on a marketing team in the restaurant, which measurement of center, it looks like I lost a little bit of that, but I can read the rest of it to you. It says, which measurement of center would you choose to advertise and why? Well, if you are working at this restaurant, I think you are going to want to advertise to say that your wait time is really, really short. So realistically, all four of these are valid numbers you could report as the center of your waiting time. But if you're trying to make your numbers look good, I would probably pick the lowest value. So in this case, I would pick the mode, since it implies the shortest wait time. And I apologize, my handwriting is even worse on these little electronic screens. But I think that is what makes the most sense. All right, so the next question here is going to be referring to measures of variance. So now I've got some sample of some NFL games from last weekend. And I've got the number of yards gained on the first offensive play. Looks like it goes from 3, 5, up to 19. First thing, I want to find the standard deviation to be able to communicate how I calculated that. So I'm going to use the calculator to do this. You can do it by hand if you'd like, but that takes a very, very long time. So instead, I'm going to bring in a calculator. All right, so on this problem, I'm being asked to calculate the standard deviation of a given data set. Same example as last time. I've got to put my data inside the calculator in a list. So I'm going to go and press stat. I'm going to edit the list. In this case, I'm going to leave my L1 there because I'm going to move on to a new list, and I'm just going to input the data. On the last entry, you can see again, list 2, number 12. That means I've got 12 data points. My value is 19. Press enter, stores that last point, and now what I can do is I can do second just press the stat button, and I need to go to calc. And again, I'm going to do one variable statistics. Here it's asking me what list I want to do it on, and I need to change that. So if my data is that I want to run the one variable statistics on is in list 2, I need to tell it to look in list 2. So I'm going to press second, the number 2. That's going to give me list 2. Arrow down to calculate, go ahead and run it, and I've got several options. The only thing I need to determine is if I'm looking for the standard deviation of a sample or standard deviation of a population. In this example, I've got just a sample of the games, so this is going to be a sample standard deviation. All right, so it looks like I've got the values that I need from my video. Now I'm just going to add those to my screen here. So standard deviation, I calculated the sample standard deviation was going to be roughly 4.7. All right, so that's excellent. And then to verify this, you'll be able to explain how you calculated the standard deviation. I'm going to walk through what I mean by that. What I want is I basically want you to show me that you know what you're doing. So essentially what you could do is just briefly list out what you did. So you put data into L2, and then you ran one var stats on L2. That tells me that you know exactly what you did on the calculator and how we did it. Okay, that's all you really need to do to get credit for that. Continuing on, looks like question little b here, or option B here. If I added a value of 25 to this data set, would it be viewed as unusual? And then I give you a nice little hint and a little reminder. I'm not going to give you hints like this on the exam on Wednesday. So just think through that a little bit. Where did I get that hint? What does mean plus standard deviation tell you? And that tells you whenever you have a mean plus standard deviation, if we're looking and dealing with normal data or bell curve shaped data, which in this course we are, then if you're outside 2 standard deviations of your mean, then your data is unusual. And that's the key thing that we're thinking about right here. So in this case, I had a mean of, let's see, my mean was from the data set, it was 10.833. I just got that from the calculator. And then my standard deviation from the calculator was 4.7. If I take the mean plus standard deviation, that's just going to give me 10.8 plus 4.7 plus 4.7, and I end up getting 20.2. So this 20.2 is really x bar plus 2 standard deviations. And we know that anything that lies outside of this this value, or anything that's larger than that, is unusual. So in this case, when we're dealing with a value of 25, that is clearly larger than the mean plus 2 standard deviations. So because of that, we would say this is unusual. You can write this by 25 would be considered unusual since it is, this handwriting is rough, since it is larger than x bar plus 2 standard deviations. That is 100% correct, and that is how you'd earn 100% of the points on the problem. Last one here, talking about the empirical rule. You can sketch an image if you'd like, and that's what I'm going to do. I'm just going to sketch a normal bell curve, and I'm going to go ahead and plot that right down here in the middle of that bell curve is going to be, and I'll plot the mean here. So I know that this is my mean, and I know that what happens whenever I've got normal data, I know that 34% of my data will have to fall on one side of the mean based on one standard deviation. So this is mean minus the standard deviation. This is mean plus the standard deviation. So I know that 34% of my data is going to fall in between those two blue areas. Whenever I add those to 34% up, I get that 68% rule, which is the first part of the empirical rule. The next part's talking about the next area here, and you know that whenever you've got two standard deviations, you're going to have much more area. So now I've got x bar plus 2 standard deviations and x bar minus 2 standard deviations. This tells me that 95% of my data will be in this green area. And really that green area is also containing the inside of the blue area as well. You know that 95% of your data is inside that. And then the last part of the empirical rule is that if you took that mean and you subtracted 3 standard deviations, or that mean and you added 3 standard deviations, you would quickly see that 99.7% of your data is within 3 standard deviations of your mean. That's a very, very cool and powerful statement, and that is what is meant by the empirical rule. Don't know why I couldn't erase that other part, but you'll get the point here. 99.7% of the data is inside all of this area here. Pretty awesome that is what is stated by the empirical rule. So hopefully you feel good about this content, and if you've got any other questions, let me know.